Welcome back, folks. It's about time to begin our next talk, and it is my pleasure to introduce Sonal. She is here to talk about an amazing product, Zing, that she's the founder of and has created, and she might have a certain entity resolution in mind for you. Sonal, take it away.
Thank you so much, Darren. An absolute pleasure to be back here at the Big Data conference. And I hope all of you have been enjoying the conference as much as I have been. So, without much ado, let me just jump in to what I'm wanting to talk about. Yeah, so I'll be talking about Zing, but more importantly, I'll be talking about identity resolution and entity resolution, the challenges that we face, the reasons why identity is important, and what are some cool ways in which identity resolution systems can actually be built. So hey, I'm the founder, and I think it's been a fun journey building up Zing. I've been very active in the data ML space and been a part of multiple conferences and committees. So again, it's a pleasure to be back here and talking about something that I've been working on very religiously over the last many years. Now, in terms of really what led me to, building Zing, I think I wanted to cover my story a bit before really diving into this problem. So, before working on Zing, I was actually leading a data consultancy and where we were building out warehouses and data lakes for companies. So, this is way back in 2013, 2014. And we were tasked with, building out Hadoop clusters and custom ETL systems, all leading to uh, some kinds of analytics and reporting on smallish, uh, tending towards big or bigger data. Now, what I realized as part of my data consultancy is, and one problem that kept coming up again and again is really trusting your data to be able to say with confidence which entities and which records actually belong to the same individual. And that was a problem that kind of flummoxed me. It kind of, hurt me in a couple of projects. And that led me to found Zing, which is an open source product so that many people can actually use it and hopefully not have to deal with the challenges that I had to deal with. Now, I think elaborating more on the problem that I saw firsthand as I was doing my data consulting, uh, enterprises have multiple systems which result because just the way enterprises are structured, the way they grow, they have different departments, they build on different systems for different needs, they have different geographies, the technology landscape evolves. There are some legacy systems, there are some open systems, multiple SaaS systems that are procured to manage sales, to manage customer relationships. And all of them eventually lead to a single customer, a single supplier, even employee information actually getting fragmented across multiple systems. Now, what happens is that if you don't have trusted and unified data of core business entities with which you want to do business with which you want to, whom you want to serve, it becomes really difficult to actually do any analytics reporting and higher order, AI ML functions. So all the investment that we put in building our warehouses, in building our data lakes, in building personalization and recommendation systems, even very simple compliance like privacy, GDPR, CCPA, how do we really do that if we don't know how many records of that customer is spread is we have actually saved, how many records have we saved, and exactly which systems hold those records. So a missing unified view actually leads to missed growth opportunities. So sales and marketing teams, the growth teams, really, their productivity is hampered because opportunities to discover cross selling and upselling, building out personalization and recommendation systems, they all get poor results because the base data itself is not ready for that. It's not unified. So we are counting five different records of that customer as five different individuals. So definitely we don't have the complete story. And if we don't know the customer that well, we cannot really service them that well. Similarly, regulatory compliance, like as I mentioned, privacy, CCPA, GDPR, anti-money laundering. If we don't know really which parties we are dealing with, it becomes really difficult to build out those fraud and analytic systems. And again, in terms of suppliers and supplies, if we do not have consolidated data, we cannot really figure out what we are spending, on whom we are spending, what are the payment terms, and maybe very likely that different geographies and different business units are purchasing the same stuff from a supplier at different terms. So there is a lot of operational compliance and analytic overhead by having this kind of this kind of data, which is spread across different systems and not unified. So this brings us to the core definition of what identity and entity resolution is. The essence of identity and entity resolution is to be able to say with conviction that we have multiple records coming from maybe same system or multiple systems, and even with different kinds of variations, even when we have not captured some information in some systems based on the schema or based on the way data is entered into them or based on the way they were designed, or typographical or other errors the user has made while entering their information, or we have captured it incorrectly, we can still say with conviction that these records actually belong to the same real world physical entity, which could be a customer, which could be a supplier, which could be a location, which could be a household. And that is the crux of what identity resolution is. We talk about resolving entities and identities, but honestly, I mean, there's a running joke in the community where we say that even identity and entity resolution is like called by so many different names. People call it user stitching, people call it identity resolution and entity resolution. There is record linkage, there's data matching, there's fuzzy matching. So that is like kind of a just, I think, just the sheer way in which this problem has been presenting to various kinds of people. Different names have popped up, but they refer to the same thing. My personal way of looking at it is that I talk about identity when it's more about humans, maybe a customer, and when I'm talking about households, I tend to refer it to as entity resolution. But that's a very personal distinction that I have kind of come up with. So similarly, you have same person logging in through different channels, mobile app, different desktops or office laptops, and being able to be to say that this person actually belongs. These all these records belong to the same individual. Now, this is a need, but then is it is it really easy to solve this? So when I kind of saw this as part of my data consultancy, we really actually bombed the project. We were nearly getting thrown out of the project because just defining these rules, sorry sorry yeah, so defining these rules to say that these records actually match with each other, that they belong to the same individual. Humanly, it's easy to say that these are actually, they are, you can say that they actually represent the same person. But for a computer which knows exact matching, which knows equality, or which knows greater than and less than, it's not easy to kind of formulate these rules and say that the first name and the last name and the address and the location, to whatever variations, they are representing the same person. On top of that, a far bigger problem, even if you somehow kind of identify the rules maybe relevant to your business domain, is the sheer complexity of scale. Now, why does scale come into entity resolution? The reason is that there is actually no unique identifier through which you can just match up all those columns and say that I want to compare them. Now, that what that leads to is comparing every record with every other record in the system. And this is a Cartesian join, which I think all of us as data people like absolutely hate. So a 10,000 number of records leads to whatever number of comparisons. But the moment you increase that size 10 folds, the number of comparisons increases 100 folds. And that leads to real scalability challenges in entity resolution. So, having really struggled with this problem, and seeing it in multiple scenarios as part of my data consulting, I wanted to create a system which had taken care of many of these challenges that I had seen. So, so I set up for Zing, we set about some design goals, which is to be able to deal with the variety of entities that typical organizations face. Now, typical organizations talk about customers, but the customer itself can be a B2B customer. So it could be an organization, it could be a B2C customer, which could be a person. And that itself has completely, so those two entities have completely different attributes. In the case of a person, you will have a first name and a last name. In the case of a company, you will probably have a domain name and an enterprise name, and other defining attributes. But entity resolution, like if you want to build like a generic purpose system, it should actually be able to handle, that is one of the design goals that we kind of set out with, is it should be able to handle like households or locations or events or products or any kind of entity, and have a system that can really understand those entities and be able to resolve them. The second challenge that was there was, to be able to handle that was the scale of the data. Now, scale of the data, because the problem itself is challenging, handling scale of the data right as part of the design becomes a critical component, because if we don't handle that, you cannot actually even look at a million records, which, or even a 500 k kind of records, which are very common across even smaller organizations, which are, maybe they have Salesforce data, they have feeds coming in from LinkedIn, they have their product data. So 400 500k is a very usual data size that companies would run within their warehouse. So, while designing Zing, scale of the data and scalability was a core design goal that we set for ourselves. Now, in terms of hard coding of rules, obviously, if you want to be able to handle the variety of entities, it is not humanly possible to define those rules up front. So then it became important that there would be no understanding or no hard coding of any rules, and should be able to handle those entities um, without any rules. Now, I think that itself becomes a challenge in itself. Like, if you don't define rules, really, how do you set out to handle all those entities? So so while working on Zing, I think it became very apparent that machine learning is a very, very important and a very suitable technology to apply to identity and entity resolution. And the reason is that those design goals automatically tend to tilt the favor in the terms of, like, using a machine learning system or building a machine learning system, because machine learning, you can learn from the data. So what that means is that there is no hard coding of rules, and because it is learning from data, you can actually work with a variety of entities. So with that, the moment you bring ML into the picture with identity resolution, those two problems or those two design goals just immediately start kind of, they you can meet them. But that still gives the challenge of scale, because ML is not a tool for scaling it. But what we kind of, when we looked at the like, various kinds of machine learning, uh, clustering is a critical part of machine learning. And we kind of looked at machine learning and thought that maybe the clustering part is something that we can borrow and use that to reduce the scale of the problem and to allow identity resolution in Zing to scale to that, to the volumes that we would like it to scale. But clustering as an ML generic purpose clustering is doesn't automatically tend itself to get applied to the clustering or the pre-clustering that we want in something like identity resolution. And the reason is that the clusters, either you know the cluster size beforehand, or typical k-means and other kinds of clustering are not for the micro clustering that an identity resolution which wants to reduce the number of comparisons to, let's say, maybe one record to be compared with only 100 near similar records. So it becomes difficult to kind of just do a standard clustering algorithm and apply it to something like identity resolution. So what that led us to kind of go to was building out a very strong indexing model, which we call the blocking model. And what that does is it actually learns from the data, the patterns, and tries to get near similar records together in very small bucket sizes, not really like break up the data into like 5 or 10 buckets, but really micro clusters. And that is what we call the blocking model. The second is the notion in Zing. We have this notion of a similarity model, which is a classifier that we use. We feed attribute level similarity, various kinds of edit distances or other kinds of metrics, similarity metrics to that classifier, and build out a pairwise similarity model. Now, once we have that similarity model, even when you've reduced the size of the problem by blocking it and getting near similar records together, then we do pairwise comparison between those records. It still gives you pairwise similarity, but we want that if a record A has matched with B and a record B has matched with C, we want them all together so that they can be verified and combined together. So in that case, we also apply, on top of this, we apply some graph algorithms, and that leads us to clustered records. Now, under the hood, as I was mentioning, there are various kinds of machine learning techniques that we use. We use AutoML, we use our inbuilt blocking and classification, we use graphs, we use active learning to build up the training data. I'll talk about that later. And we use distribution. So we chose to build Zing on a distributed system like Spark, and now we're also doing a Snowflake version, which automatically tends to favor the size of data that we want to kind of deal with, and we can scale it to even better sizes of data that enterprises want to deal with. Now, one of the key problems in adopting ML systems is having training data to go by. Now, as a machine learning system, there has to be a way in which the models get trained. There have to be some samples through which it learns. But typically, people will not have those samples. So, what really do we do? So, we went to the active learning literature and custom built um, an active learning component within Zing, which shows labeled pairs. So it shows some edge cases and some non-matches and matches to the end user. They label some pairs, and the models learn from that. They refine, and this labeling step happens a couple of times to generate a training data set through which you can actually finally train the models and build out results. Now, I think one confusion happens that when you're talking about training, do we really need to worry about every variation in the data set? What we realized is that the ML models that we generate eventually are able to generalize to the different kinds of variations. So having to hand label every single kind of variation is definitely not needed. And we've seen very good results with 40 to 50 pairs being matched, being marked as a match by the user, and that's scaling to millions of records. So eventually, when somebody works with Zing, they work on extracted and staged data, although we can connect to all kinds of data stores and sorry. data lakes, and it gives the unified and the enriched views. It Through the active learning, it learns and improves by the examples, and absolutely no machine learning or distributed engineering skills are needed to run and to deploy Zing. It's a simple question answering on a few samples of pairs Zing labeler would show to the end user, and the models can actually be trained. And we've also actually, on the open source, we've also have, as a command line execution, we have the ability to connect to absolutely any kind of a warehouse or a data lake in any format, or even RDBMS and traditional stores. Now, when we look at the Zing output, we had records which had no unique identifiers, but after running through Zing, Zing would add three columns to the output. One is the cluster, which is actually can be used as an identifier, and matching records share the same cluster ID, so that can be used as a identifier going forward. There are also a minimum score and a maximum score. What that means is the minimum, a particular record matched with any other record in the system in that cluster, and the maximum, that record matched with any other record in the cluster. And what that enables you want to do is, maybe you want to humanly review some of the data. You want to be able to automatically merge some of the data. So based on how your results look like, and what the company policy is, and what is the need of the use case in which Zing is getting deployed, these minimum and maximum scores can be used for setting up automated as well as manual review pipelines. Now that brings me to this whole, I think we started with Zing, but it also brings me to some of the foundational changes that we are seeing in the data landscape, which is the emergence of something that we call a collection of tools and technologies called the modern data stack, where there's cheap cloud storage and separation of compute and storage. And there are a lot of ready available tools through which you can stream your data, through which you can do the extraction and the loading, through which you can spin out warehouses on the fly, and build out the analytical stack. And what we see as people using Zing is part of the transformation, which is once they've extracted and loaded the data, they want to use Zing as part of the identity layer, as the transformation, build out the core entities, which they then transform either through a tool like DBT or through custom Python and other programs, which leads to the flowing back into the operational systems and the BI reporting, etc. So, like I've been talking about identity, but really, I mean, what problem does it solve? It seems that it does solve some problems, but what are the concrete cases? So let's kind of look at them. One thing that we recently discovered, and we're very happy about sharing this with you, is a fashion retailer using Zing to prevent card fraud. And this is a use case which I feel is very important in the sense of identity. Like we talk about identity a lot, about customer identity, um, and here somebody used Zing in for resolving fraudsters. And every day you have new customers signing in, or creating accounts, and you've already flagged some of the fraudsters, and you want to match against your entire data set and see. So this is like also a scale proud story for us, because they are resolving 80 million kind of customer profiles every day using Zing. And the manual approaches, obviously at this scale of data, it's very difficult to kind of work with them. A very classic use case, I think, of something like identity resolution and Zing is multi-store retail and long as well as online presence. And having a complete view of the customer is so critical. I mean, it's just, I think, the big reason why we build out all these tags, why we want to do all the personalization and the recommendation, why we want to do the segmentation. But having the identity base is so critical. So with identity resolution, one can actually power that. And the way we see some of the architectures emerging while people are using Zing is that all the first party and the third party data is either streamed or through ELT or ETL brought into the data lake or the warehouse, over which those source tables Zing builds out the golden records, and those are then used as the identity backbone of the enterprise. A use case which is very, very close to my heart, which is the North Carolina open data for campaign funds. This is a public good project, and which was sponsored by the state and done by a consulting company called Crossroads CX, and they were gracious enough to let me use their slides for this. So what happened is that, while people would donate or accept those campaign donations, the same person or the same entity, be a donor or the recipient, would be represented in so many different ways. And it was really difficult to actually track, what was a recipient getting from which donor. And that is important for transparency, for one to understand what are the leanings of the candidate, etc. So before this is typically how the data look like. And with a stack with Zing and Elastic MapReduce and Snowflake, multiple entities were resolved uh, to the same entity. And if you look at it, I mean, the spend analytics, the equation completely changes, because the attribution of who is donating what and who is getting what, once you have a clearer picture of what those entities are, it's actually data that you can really trust. So my personal view, and this is a thesis that I go by, is that identity is the it is the backbone for an enterprise data system. It is the Swiss knife for your customer 360, for your supplier 360, for your personalization and recommendation. So right from simple analytics to advanced analytics to compliance to reporting, identity is something that one should definitely keep as a Swiss knife in their data platforms. And I would strongly urge people who are part of this talk here today to join this identity movement. We are 250 members strong on Slack now. We have got a lot of love from the community, and we would love it if you come and using, and it's all open source. So use give us feedback, let us know how it goes for you. Tell us what are the creative places where you're using Zing, and help us make it better. So that's pretty much what I wanted to kind of talk about today. And I would really, really love it if people check it out and let us know what's working for them, what's not working for them, what else we can build for you. And I would love for your questions and for your support. So thank you for joining today, and open to questions.
Oh, apologies for that. Just had to find the button. Great talk there, Sonal. Thank you very much. So yeah, of course, if anyone's got any Q&A they want to have answered, feel free to throw the questions in now. It looks like we've already got one coming through from Miyako. It looks like they've asked, can you describe the generic approach in Zing to reduce the number of comparisons required for plain entity resolutions?
Yeah, so that's a great question. Something that I think we should write more about, but we've not really done a good job at. Yeah. So I talked a bit about the microclustering kind of algorithm that we use. So what essentially we do at Zing is that we look at multiple hash functions. And so a hash function is like, let's say we're looking at date of birth. We can just look at, so we can just hash and say, let's let's hash by year.
Mm.
And what that means is that, people with the same year will fall in the same bucket. So we apply various kinds of hash functions, and which function to apply and which combination of functions to apply, that also we learn from the user labels. So
Okay,
the labeler that I had shown to you earlier, let me go back to that.
sure.
So this is where the user actually says whether two pairs actually, are matches or non-matches. And this information, not just for the classifier, but also for the blocking, we use to pick and choose which hash functions we should use, and in what order, on what attributes. So that is broadly how Zing does the blocking.
Okay, fantastic. And George coming in asking, can I influence the weighing of the semantics of the fields? So, for example, can I adjust the scoring by saying, I don't care so much about that field, I care very much about this field, though?
Yeah, sure, absolutely. So, what we've done in Zing is that we have, one is the notion of what field you still want in the output. Like, let's say you have an identifier from, your source system. You definitely want it to appear in your output, but you don't want any matching or any kind of, processing to happen on that. So we have this concept of don't use attributes, or attributes which you can, just transport in a way to your output without, from your input to your output, without any matching or any kind of, criteria being applied to them.
Mm.
Secondly, we so one of one thing that I kind of missed while talking, I think you caught me here, is really what is the, field weightage, which is, I think, your question. The auto ML thing that I talked to you about automatically figures out, based on the labeling that you're doing, which attributes you're actually assigning more, weightage to. So one doesn't have to really honestly worry about, the weightage. Zing internally automatically figures out the weightage based on what you are labeling. So let's say, I am saying that I want, I'm like, let's say I have five fields. And even when my fifth field, which is, let's say, date of birth, doesn't match any single time, and absolutely doesn't match at all, I still call those records a match. Zing will infer that probably we don't want to, attach that level of weightage to that field. So that happens by itself. One doesn't have to really go in and do it.
Very handy. Another question coming in from Mirko. They ask, there's a lot of academic research work on entity resolution techniques. Is Zing based on some of these common techniques, and or have you provided new techniques or state-of-the-art papers that you've essentially applied to your work here?
Yes, absolutely. So there has been a ton of academic research, and I think new research keeps coming. In almost every academic conference would have at least one or two papers on entity resolution. I
Mhm.
make it a point to study them. But Zing, I would say, is a combination of many techniques. Um, and it's not one single paper or one single technique, because entity resolution, as I said, like, there are various challenges. So many challenges are, part of some academic paper or not. Maybe the way we've implemented them, we've definitely picked up a lot of ideas, I would say. But it's not a straight, implementation. Sometimes you're lucky, you just find one paper you can implement, and it works. Zing is more a lot of research on those academic research papers, and then coming out with a system holistically that works, that connects to the modern data systems, and not just, CSV files. And then you can train it, and you can, so I that's where I would say it is.
Got it. You've essentially used those documents as a kind of founding
Definitely.
principle to expand upon, right? Yeah.
Yes, lots and lots.
Fantastic. Okay. Well, in that case, Sonal, I believe that about rounds us out. If anyone has any questions, of course, I'm sure you're available to be reached out to, right, on the matter. Um, other than that, I think everyone right now, there's a kind of rumble in their belly because I believe it is around lunchtime, means we're going to go to an hour break. But once again, so Absolute pleasure to have you on. Really informative, and I look forward to seeing more of Zing in the future.
Thank you. Thank you so much, Darren. And thank you everyone who attended. Feel free to reach me out on my Sonal at Zing.ai is my email. But you can catch me on LinkedIn or Twitter, wherever you feel you're more comfortable, or on our Slack. Come join us.
Fantastic. Thank you, Sonal.
Thank you. Thank you. Bye bye.
Goodbye. Okay, so that means we're gonna have an hour break now. Remember, like, that's the way the schedule works. You need to eat at some point, and we decided to slot for it. Allows everyone working behind the scenes to also get some food as well. So go enjoy your break. Maybe catch up on some of the other talks. Remember, we have 3 different channels operational at all times on different matters, right? We've got data management, we've got machine learning, cloud and streaming, as well as various other discussions always going on. So check those out. And in about an hour's time, we'll be back with our next speaker. So make sure you don't miss it. I'll see you then.